In this video, I'm going to be explaining how to use the chain rule multiple times if we have a multi-layered composite function or nested function. When we use the chain rule, we're taking the derivative of the outside or outermost function, keeping the inside function the same, and then multiplying by the derivative of the inside function. So if we have multiple layers, we're just going to do that step multiple times. So for instance, if I have this nested function where h is being plugged into g, and then that output is being plugged into f, we got 3 layers. I'm going to use my chain rule 3 times. So I'm going to find the derivative of the outside function f, and I'm going to keep the inside functions the same. And then I'm going to move to the next layer. I'm going to multiply by the derivative of the next level, which is g, the derivative of g, and then keep the inside of that function the same. And then move to the next layer and multiply by the derivative of the inside function. And we could do that all day long. Here we only had to do it for 3 layers. So a lot of people describe that as like peeling apart an onion, just working apart the layers from outside to inside. We see it a lot when we have trig functions that have multiple layers. For instance, I have a sine function cubed. The sine of 4x is all cubed. I could rewrite my exponent, put it on the outside here, and that may help us visualize the different layers a little bit easier. So I'm going to take the derivative of that outside layer, something cubed. I'm going to use my power rule, drop that exponent to the front, subtract 1, and keep the inside layer the same. I'm going to multiply by the derivative of the next layer. The next layer is the sine of something, so the derivative of sine is cosine. And then I'm going to keep the inside function the same. Then I'm going to move to the next layer, 4x. I'm going to find the derivative of 4x, which is 4. And now we are almost done. We just got to simplify, multiply 3 and 4, put that number at the front, and we got our final derivative. We could also rewrite any trig function raised to a power by placing the exponent next to the trig name. We could have left it in this form as well, and that's okay. So 3 layers there. That's as much as we'll do in this class. We could do another example with a different type of function just to practice. Here I have the quantity 2 to the 4th minus 3 squared, and I'm taking the cube root of that. I could rewrite my cube root using a fractional exponent, and that will help us visualize the different layers. So we got 3 layers. We got 2 to the 4th minus 3. We got that squared, and then that all to the cube root or to the 1/3 power. So use your power rule. Find the derivative of something to the 1/3 power. I'm going to bring that 1/3 to the front and subtract 1. 1/3 minus 3/3 is negative 2/3. Keep the inside layers the same and move on to the next layer. So I'm going to find the derivative of something squared. I'm going to use my power rule again. Take that 2 to the front and subtract 1 from the exponent and keep the inside layer the same. Move on to the next layer, that being t to the 4th minus 3. Find the derivative of that, and we get 4t cubed. Now we just got to simplify it all. 2 and 4t cubed times 1/3 is 8t cubed over 3. Here, if I simplify, I got a power raised to another power, so I'm multiplying my powers or multiplying my exponents. 2 times the negative 2/3 is negative 4/3, and I still have this t to the 4th minus 3. I could then rewrite all of that, or I could keep it in this form. We could simplify one more time. I got t to the 4th minus 3 and another t to the 4th minus 3. If I'm multiplying 2 bases that are the same, I add their exponents. So negative 4/3 plus 3/3 right here gives me a negative 1/3. I could then keep it in that form. Or I could rewrite it by placing that negative exponent on the denominator. We could also rewrite that using a radical and have the cube root. So lots of different ways we could simplify and write our final derivative. But really, all of that was unnecessary because we always need to make sure that we're rewriting or simplifying functions as much as possible before finding the derivative. Because oftentimes that simplifying or rewriting step will make the derivative much easier to find. So rather than using this multiple layer chain rule, if I had just simplified at this step by multiplying my powers, the power of a power means I multiply my exponents, I could have simplified that function to t to the fourth minus 3 to the 2/3 power. 2 times 1/3 is 2/3. And now I just have two levels of a chain rule, and that's much easier to derive. I take that power to the front, subtract 1 from it, get negative 1/3 power, and then multiply by the derivative of the inside. So this is only a 2-layer chain rule rather than a 3-layer, a little bit easier, and I'm basically almost to that last step that we got down here without having to go through all of this mess. So again, always rewrite or simplify first whenever possible before finding a derivative. Oftentimes it will help and the derivative process will be easier. But with those trig derivatives, oftentimes there's no real way to simplify it first, and you may have to use the chain rule multiple times. So good luck doing it.